All right, y'all, this is going to be a pretty quick video. This is the rational zero theorem, so here we go. All right, so as opposed to testing random values and determining if they are factors, okay, so specifically, right, we're still talking about polynomials, all right? So, for example, testing if x minus 2 is a factor of that crazy-looking polynomial, right? Huge numbers, not very fun, and we would be kind of sitting here testing what on earth are my zeros, right? I basically have like an infinite pool to look from, right? I could be testing x minus 1. I could be testing x plus, x plus 1. I could be testing x plus 22. I don't know. It's just random numbers, right? I could sit here forever and test those values. That doesn't sound very fun. Okay, so some maniac discovered the rational zero theorem. Okay, because I said some maniac because I just think this thing's crazy. But it's just a weird random thing. Anyways. So the rational zero theorem. They discovered the rational zero theorem to now kind of condense that pool to a finite number, right? Because again, we could be sitting here and testing x minus 127 as a root. I don't know, or as a factor, right? We don't know. So we limit that massive infinite pool to a few numbers. If we can do that, then it saves us a lot of time, and so therefore it's saving high schoolers everywhere. Okay, now this textbook version, I do want to mention, you could take a look at the textbook, and really that's true for all of our topics. The textbook you can access through class link. If you click McGraw-Hill, it's like the red icon. You can get our textbook there. It's a good resource. It has a lot of good detailed explanations and everything like that, but there's also a different explanation in the textbook if you like that one better. But here's kind of the skinny. All right, so here it is, the rational zero theorem. Okay, and again, this is used. We use it to find the possible rational zeros. Now, what I mean by the rational zeros is you're going to have sum as fractions. Essentially, that's what it is. Okay, so again, we're taking that infinite pool of possibilities and we are limiting it down to just a few possibilities. Okay, that's what the rational zero theorem does. So, step one: find the factors of a sub 0 and list as numerators. Okay, and I'll talk about what a sub 0 and a sub n mean in just a second. Find the factors of a sub n. Okay, list them as denominators. Okay, step 3, divide all combinations. Okay, and then number 4, test your luck in order to factor. Okay, so for example, all right, so here we go. Here's an example. List all the possible rational zeros for f of x is equal to that particular polynomial. Okay, so let's go ahead and just follow this step by step and kind of, you can compare if you want. Okay, so we'll be comparing these steps in here. Okay, so step 1, find the factors of a sub 0. So let's talk about what a sub 0 is. Okay, a sub 0 is my constant. Okay, a sub 0 is my constant. So I'm going to go ahead and label that just so you have it. This is my a sub 0, and then this is my a sub n. Okay, so step number 1, find all the factors of a sub 0. So I'm going to go ahead and write factors of 8. Okay, factors of 8. And we are going to list them as numerators, but for now, let's just list them. Okay, so factors of 8. Now, I do want to note, okay, this is something important. You want to do plus or minus for everything, okay? And you'll see it as we go. So what I mean by this is, for example, a factor of 8 it would be something like 2, because I can divide 8 evenly by 2 and get out 4. 2 is a factor of 8. Okay, 4 is also a factor of 8 because I can divide 8 by 4 evenly and get out 2. Okay, so here are the factors. We've got plus or minus 1. Okay, and that's what I mean by that plus or minus. Okay, positive and negative, those are both fair game here. Okay, so plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Those are all integer factors of 8. Okay, now what I mean by integer, right, is whole numbers. Okay, essentially whole numbers, 1, 2, 3, 4, 5, etc. You're counting numbers and then you're including the negatives as well. Those are your factors as factors of 8. Step 2, find the factors of a sub n. Okay, my a sub n is 3. So factors in this particular one, I'm going to find the factors of 3. Well, this is plus or minus 1 and plus or minus 3. Not much else. Right, these are my integer factors. Okay, divide all combinations. So now this is where in step 3, I'll go ahead and put these as numerators and denominators. So what I'm going to do is I'm going to put my factors of 8, which is my a sub 0, my constant, on top. Okay, so I put plus or minus 1, plus or minus 2, just pulling from this up here, plus or minus 4, plus or minus 8. I'm dividing by these. I put these as the denominator, plus or minus 1, and then plus or minus 3. Okay, so step 3 says divide all combinations. So now what I'm going to be doing is I'm going to be listing all of my combinations. Okay, I'm dividing each of these. So for example, I divide 1 by 1. I divide 2 by 1, 4 by 1, 8 by 1. And I'm going to do the same thing with 1 divided by 3, 2 divided by 3, 4 divided by 3, and 8 divided by 3. So here we go, right? And it's easy when you're dividing by 1 because they end up just being the same number that's on top. So my first ones, right, 1, this is 1 over 1, 2 over 1, okay, that's going to be 2, 4 over 1, that's going to be 4. And then my last one for the dividing by 1, that's going to be 8. Okay, now for the other ones, I've also got fractions. Okay, that's where the kind of rational zeros comes into play. Okay, so I've got 1 divided by 3, so plus or minus 1/3, right? 1 divided by 3 plus or minus 1/3. Okay, over here I've got 2 divided by 3. Over here I've got 4 divided by 3. And finally I've got 8 divided by 3. So 8/3. Okay, plus or minus for each of these. Okay, so those are my possible, my possible rational zeros. Okay, now step 4. Okay, it says test your luck. That's what it says. So now I have this pool of numbers I can choose from. Okay, I have this pool of numbers I can choose from, and essentially what I'm trying to do is I'm going to test a few of them. Okay, now I'm going to cheat a little bit here in a sense because this is technically, you can use synthetic division and different things like that to test it out. Okay, but I'm going to use my calculator here to save us a little bit of time and save us a little bit of understanding and trying to really get at the core of what we're doing. Okay, so again, these are my possibilities. Okay, now I know that looks like a lot of possibilities, right? But think about some of the numbers that we've rooted out, right? I don't have to even think about testing plus or minus 3. It's not in here. Okay, I don't think about having to test plus or minus 9. It's not in this list, right? Otherwise, I would have an infinite list to choose from. Okay, so step 4, test your luck. I'm going to be skipping the testing your luck by doing something a little bit different. I'm going to use my calculator. I already have this polynomial in, okay? And I'm going to cheat a little bit, look at the table, okay? And I'm going to find that 4 is a, since I plug in x is equal to 4 and get out a 0, a y value of 0, I know that 4 is one of my factors. Okay, so I'm going to go ahead and we're actually going to factor this entire thing now using the possible rational theorem, or rational zero theorem. Okay, I found that 4 is a 0. So in other words, right? In other words, I'm now doing synthetic division with that 4, and again, this tells me it is one of my options, so that's good. And I'm going to, let's get rid of this, we don't need this anymore. I'm going to do synthetic division with this up here, so 3, -7, -22, +8. Bring down the 3. We're starting synthetic division. Okay, 4 times 3, that gets me 12. Okay, -7 plus 12, that gets me 5. 4 times 5, that gets me 20. -22 plus 20, that gets me -2. 4 times -2, that gets me -8. And good thing that I did get a 0 here because that was what we had already essentially confirmed with this 4, and you get out 0. Okay, so what we have now is we have a new polynomial. Okay, so what we now have is, right, this originally was, 3x cubed minus 7x minus 22x and then plus 8. Now what we have, because of this 4, right, my f of x, just keeping track, I'm now at x minus 4. Okay, right, x minus 4, and then this part, okay, is the 3x squared. Okay, and then plus 5x minus 2, no remainder. Okay, that's what I have now for this value up here. Okay, for this polynomial. Now, if it was just asking for, what is this divided by x minus 4, right, we would just have this part. Okay, but since I'm asked to factor it, I want to keep this in, right, because factored version is just, you're breaking it apart into pieces that you can multiply. Okay, so x minus 4 here. Now I've got to factor this part. Okay, so factoring this part, let's talk about our options. I've got x minus 4. Okay, and typically, I mean really not all the time, but typically your problems, you kind of just keep doing that. You keep breaking it down into these until you get something that's a quadratic like this. Okay, and then when we have these quadratic, that's when we are splitting it, guys, like this, right? And then you've got 3x here, okay, and you've got x, right? And then you kind of fiddle around with it, hopefully, but you should end up getting, let's see, you should get, we want a 2 here, a plus 2 here, and then a minus 1 here. And again, the reason I know that, right, is because if I were to multiply negative 1 times x, I'm going to get negative x. So I'm just remembering that in my head, negative x. And if I were to multiply 3x times 2, I would get 6x. So 6x minus 1x does give me that 5x. This is like your, excuse me, reverse FOIL going from here to here, right? If you were to FOIL these out, you should get back to this point. Okay? So that is your factored version for that original polynomial. So that possible rational zero theorem is a tool to limit your options for what could possibly be a zero. These are not all zeros. Okay, let's not get that confused. These are just possibilities, and what was an infinite pool of possibilities is now a finite pool of possibilities. I just can test these and see what's going on. And the one that it happened to be was the ones that it happened to me. Let's just go ahead and look at it. Were positive 4. Okay, this 0 is going to be my 1/3, so that's here, right? And then this 0 is my negative 2, so that's here. Okay, so those are the zeros that it ended up being. It has 3 zeros for that particular polynomial. Okay, that's the rational zero theorem. Again, step 4, we were essentially factoring, using the information we found with the rational zero theorem. Okay, that's that. Y'all take care. Y'all have a great day.